Hi everybody, welcome to lesson number 11 in the series called Decoding Algebra. Topic that we're going to discuss today is that of maxima and minima, and we're going to discuss a very specific problem type and a nuanced approach to this kind of question. It's called the use of Pythagorean means, right? थोड़ा सा tough topic माना जाता है, but I'm going to try and make this as simple and as basic to understand as is possible. ठीक है. Before I go ahead, quick introduction about me. My name is Anand Venkatesan. I'm an educator with Unacademy. I've been teaching for almost a decade now. I've helped students crack various entrance exams like CAT, GMAT, IFT, NMAT, SNAP, and many others. In fact, in terms of background, I'm an engineer. I've done my postgrad from IIM Bangalore. I have worked in the FMCG sector. I have also obviously trained students for the past decade. Quick sort of thing to notice is ki I don't know if you've been active on our channel yet. That's Unacademy. There are multiple channels that Unacademy has, but the most vibrant one is CAT4MBA. So do subscribe to our channel. There's tons of content that is going through in a structured manner, which means if you can follow educators, then you will find that we come live every single day, or most times in the week we come live on specific days. So you get that structure that you need to prepare, especially when you prepare online. तो एक फायदा हुआ है. दूसरा, our Telegram channels, just following them will mean that you can keep tabs on what topic is happening when, and also manage your schedule, and also marry it in case you're working, or if you're attending college, then it will help you manage your schedule, right? I've also highlighted my own Telegram channel, that's Anand for Quant, and this is where you will find updates about my YouTube videos about my upcoming sessions. Right, a couple of announcements about Unacademy. Well, results speak louder than words, and in this case you can see that plenty of students last year in CAT 2020 got 99 percentile or more. Very proud to be associated with Unacademy, and obviously you also could be one of these people to feature on the poster next year. Unacademy has also started plenty of batches. काफी सारे नए batches announce हो रहे हैं. 11th, 12th and 13th, that's Monday, Tuesday, Wednesday this week. We are kickstarting batches for CAT 2020. We kickstarted tomorrow. We kickstart another batch for the Maharashtra CET, and today is a batch that is exclusively going to cater to the PI BAT, right? The GDPI round for B school interviews, B school selections. Right? तो ये सब कुछ हो रहा है, काफी action है. The Unacademy ecosystem is going to see plenty of action. So make sure that you're part of that ecosystem. One more quick announcement. There is also a contest that happens every Sunday. This is called the Unacademy Combat. 12 बजे शुरू होता है ये हर Sunday. Make sure that you unlock it, which means that I hope that you've downloaded the app, you've installed the app on your PC or your mobile phone. To unlock it, you can use my referral code, that's AV01, and you can start contesting this in this competition. Why do you do that? Well, there are prizes to win, man. Who doesn't want to win prizes? But I think besides the prizes, I think there's also this sense of competition. है ना, किसी को हरा दिया है, can I compete? Because end of the day, CAT is like it's like a test of are you better than most? And surely you can test it by way of mocks, but you can also test it every Sunday on smaller sort of packages, on smaller areas. So I think challenge is the key. So make sure that you try it out. There are many subscription plans that are available on the Unacademy app. You can see 1 month से लेके 24 months तक काफी सारे possibilities हैं. There are options by which you can prepare 3 month, 6 month plans, but the longer term plans usually have greater value for money, and the more effective also. So make sure that you try for that. Don't forget to use my referral code AV01, gets you 10% discount on any program. ठीक है, तो आज के एजेंडा पे वापस आ जाते हैं. व्हाट डू वी लर्न टुडे? वी आर टॉकिंग अबाउट maximizing, minimizing by way of this concept of Pythagorean means. So सबसे पहले let's understand what exactly Pythagorean means are. Well, in the classical sense, there are three means that we will deal with, and these three means, I'm sure you guys have heard about them. These three means are called Pythagorean means, right? Which three means are we talking about? The easiest one, the arithmetic mean, we all have heard of it. How do I calculate arithmetic mean of n variables? Add all those variables denoted by x1, x2, x3 all the way till xn, add all the values divided by the number of values and you'll get the arithmetic mean. So if it's two variables, x plus y by 2. If it's three variables, x plus y plus z by 3. This is called the arithmetic mean, right? The notion is that an arithmetic mean is that value. I mean, you can, easiest way of understanding arithmetic mean is to, consider two variables, right? Let's say there are two variables x and y, then their arithmetic mean will be a value which if I place between a and b forms an arithmetic progression, right? So that's why it's called arithmetic mean, because it's equidistant from both a and b, right? The difference is same. The second mean is called the geometric mean, and again, if you want to get a similar sense of what the geometric mean is, then you can imagine there are two variables or two numbers a and b. तो geometric mean वो value होता है जिसको बीच में रखें, तो ratio will remain the same, right? So the ratio of, let's say the geometric mean is x, then x upon a will also be equal to b upon x, right? If a and b are the two numbers, then and if x is the geometric mean, then if x is the geometric mean, then x upon a will also be equal to b upon x, right? And so you can derive that x square will be equal to ab, and extending that logic, instead of two variables, if you have n variables, then you calculate the product of all the n variables and take an nth root. That's called the geometric mean. That's called a single value that somehow appropriates. It's called the geometric mean, right? Nth root hai, yaad rakhna hai, right? So instead of the nth average, you are calculating the nth root of the product. The third mean is called the harmonic mean. Again, harmonic mean for two variables a and b. If x is the harmonic mean, then you will say a, x and b form an harmonic progression. What is a harmonic progression? कि इनके रेसिप्रोकल्स AP में है, 1 by a, 1 by x and 1 by b will be in an arithmetic progression, which means that 2 times the middle term will be equal to the first plus the last term, right? And so if it's, so what is x? X will then be 2 divided by 1 by a plus 1 by b, right? If that's true for two variables, then for n variables it will be n, the number of variables divided by the sum of all their reciprocals. That will help me calculate the harmonic mean. Okay, right, sorry about that. ठीक है, तो ये थे, these are the three means, the three classical means, also called the three Pythagorean means, right? Now why is this important? Why are the three means AM, GM and HM important to me at all? Well, it turns out that understanding their relationships actually help me deal with maximizing and minimizing problems, right? How so? Well, the relationship between the three means is that as long as you are considering positive values, as long as all the variables that you are averaging out, as long as all of them are positive, the arithmetic mean will always be greater than or equal to the geometric mean. In fact, the entire relationship is AM. अच्छा, by the way, दो variables के लिए ये बहुत easily derive हो जाएगा, right? For two variables, AM is a plus b by 2 and GM is square root of AB and HM is 2AB upon a plus b, right? तो basically अगर आप गौर से देखोगे तो GM को अगर square करे तो वो AM into HM के equal होगा, right? So in a sense you'll say if arithmetic mean is bigger than the geometric mean, then harmonic mean should be smaller than the geometric mean, right? So this relationship comes out, but we'll actually only focus on the first part of this. We only care about the AM and the GM. We usually will not deal with the harmonic mean. हम ज़्यादातर arithmetic और geometric mean से ही derivations करेंगे, problems को solve करेंगे, right? Now why is this important? Why is arithmetic mean greater than equal to geometric mean useful to us, right? So the answer lies in the boundary condition, right? Notice karo, arithmetic mean is greater than geometric mean, but it can also be equal to. So the question is, when is AM greater than GM and when is AM equal to GM, right? तो अगर मैंने दूसरा वाला मार्क आंसर कर दिया कि AM और GM इक्वल कब होते हैं, तो अनइक्वल कब होंगे ये ऑब्वियस हो जाएगा, राइट? सो देन द क्वेश्चन इज व्हेन इज AM इक्वल टू GM, right? Now I would ideally give you some time. I could have given you, I could do that here, right? Simplest way of doing it is to see what happens when is AM equal to GM, right? So when is A plus B by 2 equal to square root of AB? Call कैसे करें? Square कर देते हैं, which means A plus B whole square should be equal to 4 times AB. अगर आप इसको expand करोगे तो this will end up becoming A minus B whole square is equal to 0. And when is that? When is the square of a number equal to 0? When that number itself is 0, which means A is equal to B, right? तो दो variables का arithmetic और geometric mean equal तब होता है when the variables themselves are equal to each other, right? So extending that logic, for n variables, the arithmetic and geometric means will be equal only if the variables are equal to each other, right? So it's established AM equal to GM if A is equal to B is equal to C, or instead if you don't like A equal to B equal to X1 equal to X2 equal to X3 and so on and so forth, right? So for equal values, the means will also become equal, specifically the arithmetic and the geometric mean, right? Okay, that's still good to know, but why is that useful to me? Well, it turns out that we will use the fact that AM is always greater than GM except when AM becomes equal to GM, right? Right? That is when X1 equal to X2, right? But now think about it. When X1 is not equal to X2, right, AM will always be greater than GM. Now इन दोनों में से अगर एक मीन somehow constant हो जाए, तो आप कहोगे कि एक वेरिएबल फिक्स्ड है, एक मीन फिक्स्ड है, दूसरा मीन चेंज हो सकता है डिपेंडिंग ऑन द वैल्यूज. लाइक लेट्स टेक एन एग्जांपल टू अंडरस्टैंड दिस बेटर. सपोजिंग आई वर टू से दैट यू हैव टू नंबर्स ए, इनफैक्ट लेट्स से देयर आर 3 नंबर्स ए बी एंड सी, राइट? सपोजिंग मैं आपको बोलूं कि इन तीनों का सम 12 है, ठीक है? ए बी और सी आर 3 पॉजिटिव नंबर्स, ए बी एंड सी are such that A plus B plus C is constant, right? Now the moment you know that their sum is constant, how do you calculate arithmetic mean? Summation of, right, A plus B plus C divided by 3. तो आपको ये दिख जाएगा कि sum पे dependent कौन सा mean होता है? arithmetic mean. तो अगर sum fixed है तो arithmetic mean will also be a constant, which is in this case equal to 4, right? So what you know is कि अगर मैं XY plane पे अरिथमेटिक मीन प्लॉट करूं, राइट, यहाँ पे अगर मैं मीन प्लॉट करूं और यहाँ पे मैं x या कोई भी वैल्यू प्लॉट करूं, तो मुझे पता है अरिथमेटिक मीन फिक्स्ड रहेगा. मैं a का वैल्यू क्या है मुझे नहीं पता, है ना? द वैल्यू ऑफ a माइट वेरी, बट इवन इफ आई कीप चेंजिंग द वैल्यू ऑफ a, द मीन विल नॉट चेंज. द अरिथमेटिक मीन एटलीस्ट विल रिमेन अ कांस्टेंट, राइट, 4. बट व्हाट अबाउट द ज्योमेट्रिक मीन, राइट? रिमेंबर ज्योमेट्रिक मीन क्या होता है? ज्योमेट्रिक मीन होता है क्यूब रूट ऑफ ABC, है ना? तो मतलब अगर मैं एक टेबल बनाऊं A और B और C का, है ना, तो and if I choose values whose sum is 12, right? So 4 4 4 is 1, right? But when 4 4 4 happens, then geometric mean is equal to 4. Cube root of 64 आएगा ना, तो 4 ही हो जाएगा. बट अगर मैं 4 4 4 ना रखूं, सपोजिंग मैं 1 1 10 रख दूं, तो geometric mean आएगा क्यूब रूट ऑफ 10. अब क्यूब रूट ऑफ 10 4 से बड़ा है कि छोटा है? राइट, क्यूब रूट ऑफ 10, obviously if I cube it I'm getting 10, obviously it's smaller than 4, है ना? In fact, any set of values that you consider, right, supposing I take 3 plus 3 9, 3 plus 3 6, 6 plus 6 is 12, right? So what is their product? 6 into 9 is 54, right? So I'm getting cube root of 54, which is still smaller than cube root of 64, right? So it turns out that when A, B and C are unequal, you will get values where GM is always going to be below the arithmetic mean, right? Which means the limiting case happens when it becomes equal. एक ही particular point होगा जहां geometric mean जो arithmetic mean के हमेशा नीचे रहता है, particular एक value पे वो GM और AM equal हो जाएंगे. And when GM and AM become equal, right, I know that the variables themselves are equal, right? But at that point, the geometric mean is the maximum possible value. The geometric mean will take the maximum possible value when AM and GM are equal, right? And this is a fact which we will tend to utilize, we will tend to exploit, right? तो इसको अगर मैं recap करूं तो point ये है कि सबसे पहले आप इसी relationship पे focus करोगे और फिर आप check करोगे. First step you'll check is AM fixed or not, right? Is AM fixed or is GM fixed, right? One of them has to be fixed or constant, right? Otherwise this method will not work, right? So you need to figure out. Supposing you get an answer, yes, arithmetic mean is fixed, right? So what will you do? You will say, okay, arithmetic mean अगर fixed है तो geometric mean तो उससे हमेशा छोटा होगा. So GM will be maximum when x1 equal to x2 equal to x3, right? And remember, AM fixed means sum is constant, right? And GM will be max means product will be maximum. Product will be a maximum value, right? And complementary's position क्या है कि हो सकता है कई बार क्वेश्चन में प्रोडक्ट फिक्स्ड दिया हो, राइट? प्रोडक्ट विच इज डायरेक्टली गोना इम्पैक्ट द ज्योमेट्रिक मीन, मे बी दैट इज अ कांस्टेंट, राइट? इफ दैट बी द केस देन जीएम इज फिक्स्ड. बट मुझे पता है एएम हमेशा जीएम से बड़ा होता है एक्सेप्ट व्हेन इट इज इक्वल, व्हिच मींस यूजुअली अरिथमेटिक मीन विल बी बिगर. सो इट्स स्मॉलेस्ट वैल्यू, एएम स्मॉलेस्ट वैल्यू or its minimum value when will occur when it becomes equal to GM, and that happens when x1, x2, x3 etc. are equal to each other. And when AM is minimum, the sum of the variables will be minimum, right? So that's the approach that we will take in solving maxima-minima problems like this, right? So to sort of put this in terms of a formula or a structured approach, you will say AM, that is the sum divided by n, will always be greater than the GM, that is cube root nth root of their product, right? And the equality happens when the variables are all equal to each other, right? But the application essentially is that check whether the sum is constant or the product is constant. If the sum of variables is constant, then the same variables will have a product which would be maximum when all of them are equal, right? Similarly, if the problem gives you that a particular product of variables is constant, then you will say then that their geometric mean is constant, and so their arithmetic mean will take its minimum value when the sum is minimum, and that happens when a1, a2, a3 etc. are equal to each other, right? So general rule of thumb क्या है कि is the sum constant or is the product constant? If the sum is constant, then the product will be maximum when variables are equal. If the product is constant, then the sum will be minimum when AM equal to GM, when x1 equal to x2 equal to x3, right? But remember, इस method में एक trap होता है कि आपको ये याद रखना है कि product उन्हीं का maximum होगा जिनका sum constant है, right? You can't add variables but multiply other forms of the same variables. Like for example, if a plus b plus c is constant, then a plus 2 into b plus 2 into c plus 2 cannot be maximized at the same value, right? That's going to be a different situation, right? Okay, let's understand this better by looking at some problems. Simple examples से start करते हैं. The most basic of problems there says there are two positive values p and q such that their sum is a constant, right? तो यहाँ पे मैं immediately यही सोचूंगा, sum is constant, which means that the AM is fixed, AM is constant, ठीक है? तो AM अगर fixed है तो मुझे पता है GM उसके नीचे ही होता है, तो GM तो at best maximum तक ही आ सकता है. So this means GM will be max when P is equal to Q, right? Are we trying to calculate the maximum value of the GM? तो क्वेश्चन में बोला फाइंड द मैक्सिमम वैल्यू ऑफ पी क्यू, और पी क्यू द प्रोडक्ट डिफाइंस द और विल हेल्प अस कैलकुलेट द जीएम. जीएम इज डिपेंडेंट ऑन द प्रोडक्ट. तो जहां पे जीएम मैक्सिमम होगा वहीं पे प्रोडक्ट मैक्सिमम होगा, और मुझे पता है जीएम विल बी मैक्सिमम व्हेन पी एंड क्यू आर इक्वल. Right? So simply put P is equal to Q, right? So you'll get P plus P is equal to 20, which means P is equal to 10, right? और अगर P 10 है, तो what is the maximum value of PQ? The max value that you wanted of the product PQ will actually be equal to 10 into 10, 100, right? So come what may, if the sum of two positive numbers is 20, then their product cannot exceed 100. It has to be at max equal to 100 only. अच्छा, ये उल्टा वाला केस कंसिडर करते हैं, राइट? एक्चुअली सेम ही हो गया ना क्वेश्चन, a plus b instead of p plus q, right? So forget this. Let's move on to this question. If a plus b equals 16, एक्चुअली मैं इस वाले क्वेश्चन में वेरिएशन बना देता हूं मैं आपको, ठीक है? So let's say this question is if a into b is equal to 64, then what is the minimum value of a plus b? So the way you'll think is that you have two numbers whose product is constant, and which mean depends on the product? The geometric mean. So geometric mean is a constant value, right? So I'm already thinking ये रहा gm fixed है, am हमेशा gm के ऊपर होता है, right? Which means am अपने minimum value तक पहुंच सकता है when it becomes equal to gm, right? So basically we'll say am will be minimum when a is equal to b, right? When the variables are equal, right? Do you want the minimum value of am? Do you want the minimum value of their sum? Yes, we do, right? So put a is equal to b and you'll get a into a square is equal to 64. Since it's a positive value, a is equal to 8 is the one that we'll be left with. And if a is 8, b is also 8, then the min value of the sum, minimum value of a plus b, will actually be 8 plus 8, 16. Right? I can't go lower than 16 in terms of sum of a and b. Even if you take small values, let's say 2 and 32 लेते हैं तो sum 34 हो जाएगा. तो 16 से कम उन दोनों का sum नहीं हो सकता है. Okay, here is a variation of the very same standard problem, right? यहाँ पे देखिए a plus b is constant, right? Now which mean depends on the sum, right? Which mean depends on the sum? The arithmetic mean, right? तो a और b का जो arithmetic mean है वो constant है, तो a और b का geometric mean, सोचो am fixed है, तो gm तो am के नीचे होता है, तो gm maximum तक पहुंचेगा. So gm is max means product can be maximized. Product of what? Product of a and b. Is that the product given over here? You want to maximize a product, but it's not a into b. It's actually a minus 5 into b plus 7. तो ये नहीं कर सकते हो, right? Don't put, right? Don't put a is equal to b, right? Because you will put a is equal to b only if you were trying to maximize the product a into b, right? But that's not what you're trying to do. Instead here, you can imagine, let's say that p is equal to a minus 5 and q is equal to b plus 7, right? So what we know is that we are trying to maximize pq. What is the maximum value of pq? That's what we want to find. The maximum value of the pq or maximum value of the geometric mean will happen when it is equal to the arithmetic mean, right? But for that, the arithmetic mean should also be fixed, right? What about the arithmetic mean? We know it depends on the sum, right? So p plus q must be a constant. Is that true? What is p plus q? This will be a plus b plus 2, which means this will be 16 plus 2, 18, right? So p plus q is 18, right? Their sum is constant, which means their arithmetic mean is fixed, and their product p into q will be maximum when p is equal to q, right? Which if p and q are both equal, then both will be equal to 9. So max value of pq will in fact be 9 into 9, that's 81, right? I can't really get any better than this value in terms of product. ठीक है, याद रखना अगर हम ओरिजिनली a और b को 8 डालते, right, तो यहाँ पे प्रोडक्ट क्या बनता है 8 minus 5 3 into 8 plus 7 15 and I would have gotten a product as 45, मतलब much lower than the actual maxima of 81. Right. Here is another question. Right. ये थोड़ा सा टेढ़ा है, अगले एक दो क्वेश्चंस थोड़े से टेढ़े होंगे because the basic ones are straightforward. No, you just need to spot that. Okay, a sum is given, I can maximize the product. Or okay, a product is given, I want to minimize the sum. Put x1 equal to x2. Right, becomes straightforward. But here it's not so straightforward. You need to adapt to the problem a little more than before. How so? So यहाँ देखते हैं, एक sum दिया हुआ है which is a constant value, right? And the question says that एक product दिया हुआ है which is maximum, right? So I mean in itself this should tell you हम Pythagorean means के problem ही solve कर रहे हैं, right? But the question here is जिनका sum constant है उन्हीं का product maximize कहाँ हो रहा है क्या? Is the product that of the same variables which are being added? Well, the answer is no, because if I multiply a into 2b into 3c, then I won't get ab square c cube, right? In fact, ab square c cube you'll only get if you multiply a with b into b and with c into c into c, right? This will be equal to a b square c cube, right? So the idea is that if this product is maximum, then the sum should also be corresponding to the sum of these variables. What is the sum of these variables? I'll have a plus 2b plus 3c, right? And I know that's equal to 18, right? So in a sense we're thinking that x1, x2, x3, x4, x5 and x6 are 6 variables, whose sum, summation of xi is 18. So their sum is a constant. Right? How about their product? Right? Their product is x1, x2, x3, x4, x5, x6, which means if I multiply I'll get a into b square into c cube, right? And the question says that the product is maximum, right? So in what case is the product maximum? Where if the sum is same, if the sum is constant and the product is maximum, when does that maxima happen, right? So I think you should remember that the maxima, right, the maxima of the product happens when a equal to b equal to c, right? All three variables are equal, which means you will get a plus 2a plus 3a, right? That's like 6a equal to 18, which means a is equal to 3, right? Now if I take this value and I substitute it in, the question says find the value of a plus b plus c, right? So if a is 3, then b will also be 3 and c will also be 3, right? But then this will become 3 plus 6 plus 9, which is indeed 18, and this one will become 3 into 3 square, that is 9 square, and this is 3 cube, 27 cube, right? So clearly this is, I can accumulate them, right? This is 3 power 1 into 3 power 9 square into 3 cube to the power 3, that's 3 power 9, right? So yeah, what am I getting? 3 power 12, right? And so the maximum value of the product that you were looking for will be 3 power 12. That's a different matter, that this question doesn't ask me for the maximum value of the product. It says when the product is maximum, find the value of their sum, right? So I know that the product is maximum with the sum being constant. Product will be maximum only if all 6 variables are equal, which means that here a, b and c will be equal. equal, then can you tell me the value of a plus b plus c? If it's equal, then it should be equal to 18 by 3. No, sorry, 18 by 6. That's 3. Right? So the correct choice is option A. Here's another variation, same problem type, p plus q plus r. If that's equal to 12, find the maximum value of p square. Now, unlike the previous question where, I had the luxury of 2b, right, which told me that I could write this as b plus b. 3c tells me that you can write this as c plus c plus c. Here, the value that you are trying to multiply and maximize actually contains 2 p's and 3 q's, but 1 r. Right? So it turns out that in variables का अगर product maximize करना है तो इन्हीं variables का sum constant होना चाहिए, right? And that's not possible because the sum of, if you add q 3 times and p 3 times, then the hotel bill will not be fair. Right? So the idea then is that I want p to be contained in 2 terms, right, when adding them, right? So the simplest way of doing that is to say write p as p by 2 plus p by 2. Similarly, I want q cube, so I want it to contain 3 terms. So why not write it as q by 3 and q by 3, and r occurs only once, so plus r will suffice, right? So if this sum is equal to 12, right, so then you are imagining, let's say these are the variables a, b, c, d, e and f. So we are saying a plus b plus c plus d plus f will actually be, right, what will their sum be? Equal to 12. Okay. If the sum of these variables is constant, can I maximize their product? Yes, I can. So GM will be max. I know that the GM will be maximum. GM will be the maximum possible value when A, B, C, D, E, F are equal. And when does that happen? Right? If all 6 variables are equal, then you will say 6A equal to 12, which means A is equal to 2, right? And if A is equal to 2, then you will say P will be 4, Q will be I don't really care about actually P, Q and R. Right? If A is 2, then what you want, in fact, we can calculate kar lete na. If A is 2, then P by 2 is equal to 2, P is equal to 4, Q by 3 is equal to 2 means Q is equal to 6, and R is equal to A, so R is equal to 2. So 4, 6 and 2. So what is the product that we want? You want to maximize 4 square. The maximum value is 4 square into Q cube, that's 6 cube into R. R will be equal to A, right? So R will be 2. So what do I get? 16 into 216 into 2. 16 into 432. Sorry about that. This is 16 into 432. 16 2s are 32. 48 plus 3, 51. 64 plus 5, 69. So 6,912. That's option A. Right? I mean, well, this might not look like a maxima-minima problem. It indeed is, right? How do you know that? देखो, product maximize कर रहे हैं, right? That's the first thing you should identify from here, right? And when you are maximizing a product, it's easy to do so if their sum is a constant, right? Is there some constant? देखो यहाँ x minus 1 into 5 minus x into 5 minus x into 5 minus x into 5 minus x into 3x minus 7. So their sum will actually be x minus 1 plus 4 times x minus 5 plus 3x minus 7, right? So 3x plus x becomes 4x minus 8 plus 4x sorry, this was 5 minus x, no? Plus 20 minus 4x right? Is this a constant? Yes. 4x cut gaya. So you'll say if this is a, b power 4 and c. So we have a into b power 4 into c to be maximized. But we need to do this when a plus b plus c seem to be adding to give me 20 minus 18 is 12. 20 minus 8 is 12. And so if a plus b plus c is 12, then I'll simply say a b power 4 c will be maximum when a is equal to b is equal to c, right? And if all three are equal, then this will be 4 4 4, right? Each of them will be equal to 4. So the maximum value of the product, the max value of in fact maximum value that you want is equal to a भी 4 है, b भी 4 है और c भी 4 है. So you'll end up getting 4 power 6. That's like 2 power 12 or 4096, right? So there you go, maxima problem, right? By using concept of Pythagorean means, right? This is how you get this done. Okay, I hope that you learned something new in today's session. Keep learning with us on the Unacademy app as well. Very soon I'm going to start sharing the schedule for my classes even on Unacademy app in the form of special classes, which means that these are classes that are free for you to attend. All you need to do is download the app and unlock special classes by using my referral code. That's and you know, there are plenty of advantages that come with subscribing to one of those plans on Unacademy, right? And those advantages are myriad. You can learn from multiple educators. The recordings are available. You can watch them anytime. You can ask doubts in the session. You can ask doubts after the session. You can submit your doubts. Somebody is going to come and answer you that for you, right? So many flexible, you know, features available on the app, right? And not the least is the fact that once you get a subscription and you choose a plan, you will see that it compares very favorably, as you know, contrasted with a classroom program, because you know, here it's a fraction of the cost, and even for the longest term, which is, you know, 2 years, the price is very reasonable, right? And I can say with absolute certainty that this is a great app. It's a beautiful app, gives you access to educators and content alike. So I think, and the code AV01, that's my referral code, can be used to get a 10% discount on any of these plans. So what are you really waiting for? Even if you're, you know, registering for one of these popular courses, make sure that you download the app. And parting words, do follow us on YouTube, do check out our Telegram channel, because that's where most of our notifications come up, right? I thank you for your time. Have a great day, have a great evening, and catch you